I'm so glad you found your way here. Your brain is processing thousands of experiences right now, deciding what to keep, what to blend, and what to release into dreams. Tonight, you'll discover why your mind builds entire worlds while you sleep, and by the end, you'll understand why you've always been a natural storyteller. Welcome to Get Sleepy Science. Wherever you are right now, perhaps wondering about dreams you barely remember, or feeling your thoughts beginning to soften and blur, allow yourself this exploration. We'll journey through 100 psychology facts about the sleeping mind. From the moment consciousness fades into darkness, to the theater where memories become stories, to the reason your brain refuses to rest even when your body does. This thoughtful journey through consciousness builds bridges between searching minds. A soft like or sharing your thoughts creates a pathway for more dreamers to discover this sanctuary of calm, one sleepy soul at a time. Your presence here nurtures our community of peaceful explorers. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Your brain creates dreams during multiple stages of sleep, not just one. For decades, researchers believed dreams occurred only during rapid eye movement sleep, when your eyes move quickly beneath closed lids and your brain shows activity similar to waking. Recent research from 2024 confirms that dreams happen throughout the night, appearing in both REM sleep and the quieter, deeper stages called non-REM sleep. Dreams during REM tend to be more vivid, story-like, and emotional, often featuring complex narratives and intense feelings. Dreams during non-REM sleep are usually simpler, more thought-like, sometimes just fragments of ideas or static images. Your brain doesn't wait for a specific sleep stage to begin dreaming. Instead, consciousness gradually shifts and transforms throughout the entire night, creating different types of mental experiences depending on which sleep stage you're in and how deeply you've descended into rest. The sleeping brain remains remarkably active, sometimes even more active than during waking hours. When you close your eyes and drift into sleep, your brain doesn't power down like a computer. Neuroimaging studies from 2024 show that certain brain regions actually increase their activity during sleep, particularly areas involved in memory processing, emotional regulation, and visual imagery. The posterior cortical regions, sometimes called the hot zone of dreaming, light up with high-frequency electrical activity during dream experiences. Your prefrontal cortex, the part that handles logical thinking and reality testing during the day, becomes quieter during sleep, which explains why dreams can feel so strange and illogical without bothering you. This pattern of increased activity in some areas and decreased activity in others creates the unique mental state we experience as dreaming, where anything seems possible. Dreams help your brain consolidate memories from the day, deciding what to keep and what to discard. Research presented at the 2024 Nobel Conference revealed that during sleep, your hippocampus, a seahorse-shaped structure deep in your brain, replays experiences from your waking hours. This replay happens much faster than real time, like watching a recording on fast forward. As these memories replay, your brain evaluates them, strengthening connections for important information while weakening connections for trivial details. The emotional core of experiences tends to be preserved while neutral backgrounds fade away. This is why you might remember how you felt during an important conversation, but forget exactly where you were standing. Your sleeping brain is constantly editing your life story, keeping the meaningful moments while letting go of the mundane. The neurotransmitters in your brain shift dramatically during sleep, creating the perfect chemical environment for dreaming. During waking hours, norepinephrine and serotonin keep you grounded in reality, helping you distinguish real from imaginary. When you enter REM sleep, levels of these chemicals drop almost to zero. Acetylcholine, another neurotransmitter, surges during REM sleep, activating the same brain regions used for visual perception and emotional processing during waking. This unique chemical cocktail explains why dreams feel so real in the moment but seem bizarre upon waking. Without norepinephrine to maintain logical thinking and serotonin to moderate emotions, your brain creates vivid sensory experiences and intense feelings without the usual reality checks that normally keep thoughts grounded and rational during your day. Your amygdala, the brain's emotion center, becomes highly active during REM sleep, which is why dreams often feel so emotionally intense. This almond-shaped structure deep in your brain processes fear, anxiety, joy, and other powerful feelings. During REM sleep, the amygdala shows increased activity, while the prefrontal cortex, which normally regulates emotional responses, remains relatively quiet. This imbalance between emotion generation and emotion regulation creates dreams that can feel overwhelmingly joyful, terrifying, or sad. Recent studies from 2024 suggest this emotional intensity during dreams serves a purpose, helping your brain process and integrate emotional experiences from waking life. Dreams may be the mind's way of practicing emotional responses in a safe environment where consequences don't exist and reality's constraints don't apply. Most dreams are never remembered, vanishing from awareness within seconds of waking. Research suggests you experience multiple dreams each night, perhaps 4 to 6 major dream periods during REM sleep, plus numerous fragments during other sleep stages. Yet most people remember only a fraction of these experiences, if any at all. A 2025 study examining the neural architecture of dream recall found that remembering dreams requires successful encoding of the experience into memory during sleep, then successful retrieval upon waking. White matter integrity in specific brain regions, particularly the orbitofrontal cortex and parahippocampal gyrus, correlates with how often people remember their dreams. The brain must be in just the right state upon awakening for dream memories to transfer into conscious awareness and lasting memory. Dreams occur in approximately 90-minute cycles throughout the night, with REM periods gradually lengthening toward morning. Your first REM period might last only 5 to 10 minutes, occurring roughly 90 minutes after you fall asleep. Each subsequent REM period grows longer, with the final REM period before morning potentially lasting 30 to 40 minutes or more. This is why people often remember morning dreams more vividly, as these longer REM periods provide more time for complex narratives to develop and a greater chance of waking directly from REM sleep when dream recall is highest. The cyclic nature of sleep and dreaming follows ancient rhythms encoded in your brain, alternating between the deep restoration of non-REM sleep and the active processing of REM sleep throughout the night. The visual cortex activates during dreams, even though your eyes remain closed, creating the sense of seeing in your mind's eye. Neuroimaging studies show that when people dream about specific visual content, such as faces, places, or objects, the corresponding regions of the visual cortex light up with activity. Your brain generates visual experiences internally, drawing from stored memories and recombining them in novel ways. This explains why dreams can feel visually rich and detailed, sometimes even more vivid than waking perception. The Dream 2 Image Project from 2025 used EEG recordings and artificial intelligence to decode and visualize dream content, demonstrating that specific patterns of brain activity during sleep correspond to specific visual experiences further confirming that dreaming involves real visual processing. Different sleep stages contribute uniquely to memory processing, with light sleep, deep sleep, and REM sleep, each playing distinct roles. Light Stage 2 non-REM sleep helps improve motor skills, like learning to type or play an instrument. Deep, slow-wave sleep is critical for consolidating factual information and explicit memories, such as vocabulary words or historical dates. REM sleep processes larger amounts of complex information and supports pattern recognition and creative problem-solving. Harvard researcher Robert Stickgold, speaking at the 2024 Nobel Conference, emphasized that you need all these sleep stages working together for optimal memory formation. Losing even one stage through sleep disruption or insufficient sleep duration can impair different aspects of learning and memory consolidation. Dreams help integrate new experiences with existing knowledge, building connections between what you just learned and what you already know. When you learn something new during the day, that information initially exists as isolated facts or skills in your brain. During sleep, particularly REM sleep, your brain replays these new memories alongside related older memories, strengthening connections between them. This process of integration helps you understand new information more deeply, seeing how it fits into broader patterns and frameworks. A 2024 study showed that participants who dreamed about a maze learning task performed dramatically better at navigating the maze the next day compared to those who didn't dream about the task, suggesting dreams actively contribute to learning rather than simply reflecting it. The hippocampus and neocortex engage in dialogue during sleep, transferring memories from temporary to long-term storage. Your hippocampus acts like a temporary holding area for new memories, while the neocortex serves as the brain's long-term storage system. During sleep, these two regions communicate through coordinated patterns of electrical activity. Sharp wave ripples in the hippocampus occur during non-REM sleep, replaying recent experiences at high speed. These ripples coordinate with slow oscillations in the neocortex, allowing memories to be gradually transferred from short-term hippocampal storage to more permanent neocortical networks. This ongoing dialogue throughout the night ensures that important experiences become integrated into your lasting knowledge, part of who you are and what you understand. Dreams may serve as emotional therapy, helping process difficult feelings in a safe, consequence-free environment. During REM sleep, stress hormones like norepinephrine drop to very low levels, creating what researchers call a safe mode for emotional processing. Your brain can revisit difficult experiences, practice responses to challenging situations, and work through complex feelings without the physical stress response that would occur during waking. A 2024 study on fear in dreams and wakefulness found evidence for day-night affective homeostasis, suggesting that processing negative emotions during sleep helps maintain emotional balance during waking hours. Dreams might be the brain's way of desensitizing you to emotional triggers, gradually reducing their intensity through repeated safe exposure. Sleep deprivation significantly impairs dream-related memory processing, highlighting why adequate sleep matters for learning. When you don't get enough sleep, particularly REM sleep, the hippocampus shows reduced reactivation of recently learned information. A 2024 study found that sleep loss diminishes hippocampal replay, the process where your brain reviews and consolidates new memories. Without sufficient REM sleep, emotional memories fail to consolidate properly, and the integration of new information with existing knowledge becomes impaired. Even a single night of poor sleep can affect memory formation. Though the effects compound with chronic sleep restriction, your brain needs those hours of darkness and dreaming to properly process the day's experiences and learning. Lucid dreaming, the ability to become aware you're dreaming while remaining asleep, occurs when the prefrontal cortex partially reactivates during REM sleep. Normally during dreams, the prefrontal cortex remains quiet, which is why you accept bizarre dream scenarios without question. In lucid dreams, this region shows increased activity, restoring some critical thinking and self-awareness while you remain in the dream state. Research from the Cognitive Neuroscience Society in 2024 explored new technology for manipulating dreams, including techniques that might help people achieve lucidity more easily. Lucid dreaming represents a unique hybrid state, combining the imaginative freedom of dreaming with the self-awareness of waking consciousness. Adult-born neurons in the hippocampus play a crucial role in memory consolidation during REM sleep. These young neurons, newly generated even in adult brains, show heightened plasticity and unique activity patterns during REM sleep. Research published in Neuron demonstrated that these specific neurons that were active during learning are most likely to reactivate during subsequent REM sleep. When scientists artificially suppressed these neurons during REM sleep, memory consolidation failed, providing causal evidence that activity in these cells during REM sleep is necessary for forming lasting memories. The brain continues generating new neurons throughout life, and these fresh cells contribute importantly to learning and memory, particularly through their activity during dreaming. Dreams involve real neural processing, not just random brain activity, as evidenced by their consistent patterns and functions. Early theories suggested dreams were meaningless noise, the brain's equivalent of static during sleep. Modern neuroscience research from 2024 and 2025 shows this view is incorrect. Dreams exhibit organized structure, follow psychological themes, incorporate autobiographical memories, and serve specific cognitive functions. The consistent appearance of certain dream characteristics across cultures and throughout human history suggests dreaming evolved for important purposes. Your sleeping brain doesn't generate chaos. Rather, it creates meaningful experiences that reflect your concerns, process your memories, and contribute to your psychological well-being. The default mode network, a brain system active during wakeful rest, also shows activity during dreaming. This network involves regions in the medial prefrontal cortex and posterior cingulate cortex, areas associated with self-referential thinking, imagining the future, and remembering the past. During dreams, this network helps generate scenarios that feel personally relevant, incorporating your memories, concerns, and sense of self. The activation of these self-referential regions explains why dreams often feel meaningful and emotionally significant, featuring people you know and situations related to your life, rather than being random collections of images and events with no personal connection. Theta oscillations in the hippocampus, rhythmic electrical patterns occurring 4 to 8 times per second, coordinate memory processing during REM sleep. These theta rhythms were once thought to occur only during waking exploration and learning. Researchers now understand they also appear during REM sleep, where they help orchestrate the replay of spatial and episodic memories. Hippocampal place cells, neurons that encode specific locations, reactivate during REM theta in the same sequences they fire during waking exploration. This reactivation strengthens the memory traces, helping you remember routes, locations, and the spatial context of experiences, building your internal map of the world. Sleep spindles, brief bursts of brain activity during light sleep, facilitate the transfer of information from hippocampus to neocortex. These spindles appear as distinctive patterns on sleep recordings, lasting 1 to 2 seconds and occurring throughout stage 2 non-REM sleep. Recent research shows that spindles coordinate with hippocampal ripples and cortical slow oscillations, creating precise windows for memory consolidation. The number and quality of sleep spindles correlate with memory performance, particularly for factual and declarative memories. Your brain generates thousands of these spindles each night, each one potentially contributing to strengthening and stabilizing newly formed memories. Dreams can incorporate external sensory information, weaving real stimuli into the narrative without necessarily waking you. If someone whispers your name, you might dream about being called. If music plays nearby, it might become part of the dream's soundtrack. A 2024 review on influencing dreams through sensory stimulation found that carefully timed sounds, scents, or tactile sensations during sleep can be incorporated into dream content without disrupting sleep. This finding has led to development of targeted dream incubation devices and techniques for potentially treating nightmares or enhancing creativity through guided dreaming experiences. The temporal lobe, involved in memory and language processing, shows increased activity during dreams, contributing to the narrative quality of dream experiences. This region helps construct coherent stories from fragmented memories and current concerns, giving dreams their plot-like structure despite lacking the logical consistency of waking narratives. The temporal lobe's activation explains why dreams often feature conversations, sequences of events, and cause-effect relationships, even when the specific content is bizarre. Your sleeping brain attempts to create meaning and coherence, building stories from the available neural activity. REM sleep shows a unique pattern, where overall brain metabolism matches or even exceeds waking levels, despite the body remaining paralyzed. This metabolic activity indicates intensive cognitive processing is occurring. Your brain during REM sleep consumes oxygen and glucose at rates similar to or higher than during alert wakefulness, powering the vivid dreams and memory consolidation processes. The paralysis, called REM atonia, prevents you from physically acting out dreams, protecting you from injury, while your mind engages in intense virtual experiences during sleep. The phenomenon of dream amnesia, forgetting dreams upon waking, involves both neurochemical and neural mechanisms. The shift from sleeping to waking consciousness involves dramatic changes in neurotransmitter levels and brain region activation. The medial prefrontal cortex, important for encoding new memories into long-term storage, shows reduced activity during dreaming, making dream memories inherently fragile unless you wake directly from a dream or immediately focus on recalling it upon waking. The memory often fades within seconds or minutes. Dreams serve multiple simultaneous functions rather than just one single purpose, reflecting the brain's tendency toward efficiency and multiple uses for the same neural processes. During dreaming, your brain consolidates memories, regulates emotions, practices problem-solving, maintains neural circuits, integrates new information with existing knowledge, and potentially simulates threats for survival preparation. These functions occur in parallel, making dreaming a sophisticated and multifaceted process rather than a single-purpose system, like an orchestra where many instruments play together, creating complex, harmonious effects. Approximately 90% of dream content involves personal experiences, concerns, and relationships from waking life, demonstrating dreams' connection to daily existence. Studies analyzing thousands of dream reports find consistent themes related to the dreamer's social interactions, ongoing problems, daily activities, and emotional concerns. Dreams rarely introduce completely random or foreign content. Instead, they remix and recombine elements from your actual life, suggesting that dreaming primarily serves to process personal experiences rather than generate completely novel scenarios. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of processes working in silence, heart beating, lungs breathing, brain dreaming, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine, You are a complete ecosystem, diverse, self-balancing. Your sleeping brain repairs itself while you rest, clearing away the day's cellular debris, preparing for tomorrow. Feel the weight of your head against the pillow, the softness beneath you. You are safe. You are supported. You are exactly where you need to be. Now we continue. Dreams actively contribute to creative problem-solving and insight, sometimes providing solutions that elude waking consciousness. Throughout history, scientists, artists, and inventors have reported breakthrough ideas arriving in dreams. The chemist, Auguste Kekulé, discovered the ring structure of benzene through a dream of a snake eating its own tail. The mechanism behind this creativity involves REM sleep's unique ability to make unexpected connections between seemingly unrelated concepts. With logical constraints relaxed and associative thinking enhanced, your dreaming brain explores novel combinations of ideas. Research shows that REM sleep enhances performance on tasks requiring creative insight, particularly those needing integration of distant concepts. The unconscious brain, freed from waking logic, sometimes sees patterns and solutions that conscious analysis misses entirely. The emotional content of dreams often reflects unresolved concerns or situations causing stress in waking life, serving as a window into psychological well-being. Dream analysis, though imperfect, can reveal patterns in emotional themes that might not be fully conscious during waking hours. People experiencing anxiety often have dreams with themes of being chased, falling, or being unprepared for important events. Those processing grief may repeatedly dream about lost loved ones. Recent research from 2024 suggests these recurring emotional themes aren't random, but rather represent the brain's attempt to process and integrate difficult feelings. Dreams essentially put emotional concerns on display, creating scenarios where you can practice responses and gradually reduce the intensity of difficult emotions through repeated exposure. Sleep disturbances and nightmares are more common in people with post-traumatic stress disorder and other mental health conditions, suggesting dreams play a role in emotional regulation. When the emotional processing function of dreaming becomes overwhelmed or disrupted, nightmares can result. These intensely distressing dreams may represent the brain's struggle to integrate traumatic memories that are too disturbing to process normally. Interventions targeting nightmare reduction, such as imagery, rehearsal therapy, can significantly improve sleep quality and daytime functioning. The 2024 Cognitive Neuroscience Society Symposium highlighted new approaches to manipulating dreams for clinical benefit, particularly for reducing nightmares in various clinical populations. Understanding how dreams normally process emotions helps researchers develop better treatments when this system malfunctions. The intensity of emotions experienced in dreams can match or even exceed waking emotional intensity, despite the dreamer recognizing upon waking that nothing real occurred. During REM sleep, the amygdala and other emotion processing regions show activation patterns similar to or stronger than during equivalent emotional experiences while awake. This explains why dream fear can trigger real racing heartbeat, why dream joy can leave you waking with genuine happiness, or why dream grief can produce real tears. The emotional experiences feel authentic in the moment because, from your brain's perspective, they are authentic, activating the same neural circuits that process emotions during waking life. Only upon waking does the prefrontal cortex label these experiences as just dreams. Dreams may help maintain and strengthen neural circuits even when those circuits aren't being used during waking hours, similar to how virtual practice maintains skills. If you learn a skill like juggling or speaking a foreign language, then stop practicing. You'll lose proficiency. However, if you dream about these activities, the relevant neural circuits remain more active than they would otherwise. This use it or lose it principle applies throughout the brain. Dreaming might serve as neural exercise, keeping connections alive and functional even without external input. The sleeping brain activates various circuits randomly or semi-randomly, preventing the degradation that would occur from complete inactivity, essentially rehearsing skills and maintaining capabilities during sleep's downtime. Recent research from 2025, using artificial intelligence to decode dreams from brain activity, shows that specific patterns of neural activity correspond to specific dream content. The Dream2 image dataset, combining EEG signals with dream transcriptions and AI-generated visualizations, demonstrates that it's possible to identify what someone is dreaming about based on their brainwaves. This breakthrough suggests dreams have consistent neural signatures that can be detected and interpreted. While we're still far from reading dreams like watching a movie, these studies prove that dreams aren't random chaos, but organized experiences with predictable brain patterns. Your sleeping brain generates content that can be partially decoded from outside observation. The transition from waking to sleeping involves gradual changes in consciousness rather than an abrupt switch. As you fall asleep, you pass through a transitional state called hypnagogia, characterized by fragmented thoughts, visual imagery, and occasional auditory sensations. This in-between state sometimes produces vivid hallucinations or the sensation of falling, known as hypnic jerks. The boundary between waking and sleeping is fuzzy, with consciousness dimming gradually as different brain regions decrease their activity at different rates. Some parts of your brain fall asleep before others, creating this twilight zone, where elements of waking thought blend with the beginning of dreams. Dreams exhibit what psychologists call bizarreness, accepting impossible or illogical scenarios without question. You might fly without wings, meet deceased relatives, or find yourself suddenly in a different location, and none of this seems strange within the dream. This acceptance of impossibility occurs because the prefrontal cortex, which normally evaluates reality and maintains logical consistency, operates at reduced capacity during REM sleep. Without this critical evaluation system fully engaged, your dreaming mind doesn't flag contradictions or impossibilities. The dream simply is, and you accept it, creating a world where the rules of physics, logic, and possibility don't constrain experience. Sleep-dependent memory consolidation follows what's called the synaptic homeostasis hypothesis, where sleep helps restore the brain's capacity for learning. During waking hours, learning and experience strengthen synaptic connections throughout your brain. If this strengthening continued unchecked, synapses would eventually saturate, losing their ability to encode new information. Sleep, particularly non-REM sleep, helps downscale these connections, restoring a baseline that permits further learning the next day. This process doesn't erase memories, but rather optimizes the brain's information storage, keeping the most important connections strong while weakening less critical ones, maintaining the brain's capacity for ongoing learning. The continuity hypothesis of dreaming suggests that dream content reflects waking life concerns, thoughts, and experiences, showing substantial continuity between sleeping and waking mental activity. Studies analyzing dream journals find that the people, places, and concerns appearing in dreams largely mirror those significant in the dreamer's waking life. If you're worried about work scenarios appear in dreams. If relationships matter most, dreams feature social interactions. This continuity challenges the idea that dreams are random or meaningless, instead suggesting they represent continued cognitive and emotional processing of waking life concerns during sleep's altered state of consciousness. REM sleep shows a fascinating paradox, where the brain is highly active, but the body remains mostly paralyzed. This paralysis mediated by neurons in the brainstem, prevents you from acting out dreams. When this system malfunctions, people may physically move during dreams, a condition called REM sleep behavior disorder. The paralysis demonstrates how carefully the brain separates virtual experiences from physical action. Your muscles receive active inhibition signals during REM sleep, essentially disconnecting the motor system, while the brain generates vivid, immersive experiences that feel completely real within the dream. Dreams can incorporate sensory experiences that feel completely realistic, engaging all 5 senses despite no actual external stimuli. You might taste food, feel textures, smell fragrances, hear sounds, and see vivid imagery, all generated entirely within your brain. Research shows that sensory cortices activate during dreams corresponding to the dream content, creating genuine subjective experience without external input. The brain essentially hallucinates a complete multisensory world, drawing from stored sensory memories and recombining them into new experiences that feel as real as waking perception while they last. The sleeping brain prioritizes emotional memories over neutral ones, a process that continues throughout the night. Multiple studies from 2024 show that emotional content receives preferential consolidation during sleep, particularly during REM sleep periods. This emotional bias means you're more likely to remember emotionally significant events than mundane daily activities. The amygdala's heightened activity during REM sleep helps tag emotional memories for preservation while neutral background details fade. This selective consolidation ensures your autobiographical memory focuses on what matters most, the emotionally important moments that define your life. Nightmare disorder, characterized by frequent distressing dreams causing significant impairment, affects approximately 5% of adults. These aren't just bad dreams, but intensely frightening experiences that often wake the dreamer and can create fear of sleeping. Treatment approaches, including imagery, rehearsal therapy, where patients rehearse modified versions of nightmares during waking, show effectiveness in reducing nightmare frequency and intensity. Understanding nightmares as a dysfunction of normal emotional processing during dreams helps develop better interventions for those suffering from this distressing condition. The sleeping brain can process complex information and even learn new associations without conscious awareness. Research using targeted memory reactivation shows that cues presented during sleep can strengthen specific memories. If you learn to associate certain sounds with specific information while awake, playing those sounds during subsequent sleep enhances memory for the associated information. This sleep learning isn't creating entirely new memories, but rather strengthening and consolidating information already encountered, demonstrating that the sleeping brain remains receptive and continues processing information throughout the night. You're still here with me, thoughts still flickering like candlelight. Just notice. Don't judge. Just notice where your mind is. We're exploring consciousness itself. The very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Let's drift onward together. Dreams may have evolved to serve survival functions, particularly through what researchers call threat simulation theory. This hypothesis suggests dreaming provides a safe environment to practice responses to dangerous situations without real-world consequences. Ancestral humans who dreamed about predators, enemies, or environmental hazards might have been better prepared when facing actual threats. Modern dreams still feature threatening scenarios, being chased, attacked, or in danger, despite our relatively safe environment, suggesting this ancient function persists even when no longer strictly necessary for survival. Children experiencing trauma show dream patterns reflecting threat simulation theory, with dreams featuring dangerous scenarios related to their experiences. A 2005 study of traumatized children found their dreams contained significantly more threatening events compared to control groups, suggesting the sleeping brain attempts to process and prepare responses to real dangers encountered during waking. These findings support the idea that dreaming serves an adaptive function, helping individuals cope with and prepare for challenges they face in reality. The content of dreams changes across the lifespan, with children's dreams being simpler and more static, becoming more complex and narrative-driven in adolescence and adulthood. Young children often report brief dreams with simple imagery and less plot development. As the brain matures, particularly the prefrontal cortex, dreams become more elaborate, featuring complex social interactions, extended narratives, and more sophisticated emotional content, reflecting the increasing cognitive complexity of the developing brain. Women and men show some differences in dream content, with women typically reporting more characters, more indoor settings, and more emotional content in dreams, while men report more physical aggression and outdoor settings. These differences may reflect socialization, daily life experiences, or biological factors influencing dream generation. The emotional tone of dreams also shows gender differences, with women more frequently reporting dreams involving anxiety or fear compared to men's dream reports. Dreams can incorporate recently learned information, a phenomenon called dream incorporation or day residue. Events from the previous day often appear in dreams, though usually transformed rather than replayed exactly. The way waking experiences appear in dreams provides clues about how the brain selects and processes information for consolidation. Not every experience makes it into dreams, only those tagged as significant or relevant, suggesting selective processing rather than random inclusion. The sleeping brain can solve problems that stumped you while awake, sometimes presenting solutions in dreams. This insight often comes from REM sleep's ability to find unexpected connections between distant concepts. When you sleep on a problem, your brain continues working on it, freed from the constraints of linear, logical thinking. The solution might appear directly in a dream or simply feel clearer upon waking after sleep's unconscious processing. Dream reports from people blind since birth reveal dreams rich in sound, touch, taste, and smell, but lacking visual imagery, demonstrating that dreaming engages whatever sensory systems are available. Those who lost sight later in life continue experiencing visual dreams, drawing from visual memories stored before vision loss. This shows dreams don't require external sensory input, but rather work with the brain's existing perceptual systems and memories. Across human cultures, dreams have been attributed spiritual or prophetic significance, though modern neuroscience suggests they're products of brain activity rather than messages from external sources. Nevertheless, the universal human tendency to find meaning in dreams hints at their psychological importance, even if not supernatural. Dreams feel meaningful because they engage brain systems involved in personal concerns, emotions, and autobiographical memory. Some medications significantly affect dream content and recall, particularly antidepressants influencing serotonin and norepinephrine systems. SSRIs can reduce REM sleep and decrease dream recall, while their withdrawal sometimes causes vivid dreams. Beta blockers, used for hypertension, can increase dream vividness and nightmares. These medication effects demonstrate how delicately balanced the neurochemical systems underlying dreaming are. We've reached the halfway point of our journey. Your brain creates dreams because it must process, integrate, and make sense of experience. Dreaming isn't optional, but essential, as fundamental to brain function as breathing is to the body. The question isn't whether to dream, but what those dreams reveal about the mind's ongoing work during sleep's darkness. Take a moment to feel your breath moving slowly in and out. You're resting here, halfway through the night's exploration. The universe continues to expand, stars continue to burn, Time continues its endless flow, but this moment, this breath, this second of existence, belongs only to you. Your time is unique in all of history. No one else occupies this exact moment of consciousness. Imagine you're floating on a calm lake, the surface gentle beneath you, supporting you completely. Beneath the surface, deeper currents flow, unseen but always present, like your dreams, moving beneath awareness, doing their quiet work while you rest. Let each breath guide you deeper into stillness. Now we continue drifting. Your personal dreams reflect your unique life, concerns, and psychological makeup, creating a dream world that belongs to you alone. No two people dream identically, because dreams draw from individual memories, experiences, relationships, and emotional patterns. Dream content serves as a window into personal psychology, revealing what matters most to you, what worries you carry, which relationships occupy your thoughts. Analyzing your own dream patterns over time can reveal themes and concerns not fully conscious during waking hours. Your dreaming mind knows you intimately, understanding your fears and hopes, continuously working to integrate your experiences into the ongoing story of who you are and who you're becoming. The brain's reward system, involving dopamine pathways, shows altered activity during REM sleep compared to waking. This shift may influence the emotional tone and motivational content of dreams. Reduced dopamine in certain pathways might explain why dreams sometimes feel aimless or lack the goal-directed behavior typical of waking thought. The reward system's involvement in dreaming suggests dreams process not just memories and emotions, but also motivational states and desires. Dreams sometimes feature deceased loved ones, providing what many describe as comforting visits or opportunities for closure. From a neuroscience perspective, these dreams involve activation of memory networks, storing representations of the deceased person. The emotional significance of these relationships means they remain strongly encoded in your brain, making them available for incorporation into dreams. Whether experienced as spiritual encounters or neurological phenomena, these dreams often provide genuine emotional comfort and can facilitate grief processing. The sleeping brain shows increased connectivity between distant brain regions during certain sleep stages, potentially explaining dreams' ability to make novel associations. This enhanced, long-range connectivity allows your brain to link concepts and memories that don't normally connect during waking thought. Such connections can lead to creative insights, unexpected problem solutions, or simply the bizarre juxtapositions characteristic of dreams. Dream interpretation, practiced across cultures for millennia, remains controversial in modern psychology. While dreams clearly reflect personal concerns and emotional states, the idea that specific dream symbols have universal meanings lacks scientific support. The most defensible approach to dream interpretation focuses on the dreamer's personal associations and current life context, rather than fixed symbolic meanings. What matters most is how the dreamer relates to and makes sense of their own dream experiences. The frequency of dreams about flying, falling, or being chased appears relatively consistent across cultures, suggesting these themes may relate to universal human experiences or brain processes. Flying dreams might relate to feelings of freedom or escape. Falling dreams often correlate with anxiety or loss of control. Being chased may represent avoidance of difficult situations. However, the specific meaning varies by individual context and cannot be universally prescribed. Dreams during pregnancy often feature themes related to the baby, birth process, or anxieties about parenting. These dreams reflect the psychological processing of the major life transition underway. Hormonal changes during pregnancy may also influence dream frequency, vividness, and emotional intensity. The brain uses dreams to work through fears, hopes, and preparations for the significant changes ahead. Your sleeping brain generates approximately 12,000 to 15,000 dreams over an average lifetime, though most vanish immediately upon waking or soon after. This vast library of nighttime experiences represents countless hours of your brain actively processing, creating, and exploring. Each dream, remembered or not, contributes to the ongoing work of memory consolidation, emotional regulation, and neural maintenance. The sense of self persists in dreams, even when experiencing bizarre scenarios or inhabiting different identities. The default mode network's activity during dreaming maintains a coherent sense of self as the experiencer of dream events. This continuity of self, even in dreams' altered reality, suggests that core aspects of identity remain active and intact during sleep. Dreams can reflect not only personal psychology, but also social and cultural influences. People in societies with different cultural norms, values, and daily experiences show corresponding variations in dream content. However, certain universal themes appear across cultures, suggesting both cultural specificity and human universality in dreaming. The practice of keeping a dream journal can increase dream recall over time, as the act of recording dreams signals to your brain that these experiences are worth encoding into memory. Regular recording may strengthen the neural pathways involved in transferring dream content from sleep to waking awareness, making dreams more accessible upon waking. Recurring dreams, where similar themes or scenarios repeat across multiple nights or even years, often indicate unresolved emotional issues or ongoing life stresses. The repetition suggests the brain continues attempting to process or integrate something that hasn't been fully resolved. Successfully addressing the underlying issue, either through psychological work or life changes, often leads to the recurring dream's cessation or transformation. The neuroscience of dreaming reveals that consciousness exists on a spectrum rather than as a simple on-off state. Dreaming represents a distinct mode of consciousness, different from both waking and dreamless sleep, characterized by vivid subjective experience combined with reduced voluntary control and critical thinking. Your brain's language centers remain partially active during dreams, enabling dream conversations and inner speech. However, language processing during dreams differs from waking, sometimes producing made-up words, nonsensical phrases, or difficulty reading text. The altered language processing reflects the reduced prefrontal involvement in organizing and monitoring linguistic output. Dreams about being unable to move, speak, or scream sometimes occur during sleep paralysis, a state where consciousness returns before the body's REM paralysis has lifted. This can create a frightening sensation of being awake but unable to move, sometimes accompanied by hallucinations. Sleep paralysis is generally harmless, though disturbing, and understanding its neurological basis can reduce associated anxiety. The sleeping brain shows spontaneous activation patterns that don't simply replay waking experience, but create novel combinations and scenarios. This generative aspect of dreaming distinguishes it from simple memory replay and may contribute to creativity and flexible thinking. Your brain doesn't just review the past during sleep but actively generates new possibilities. Dreams influence mood upon waking, with dream emotional content affecting how you feel in the morning. Pleasant dreams can leave you feeling refreshed and positive, while disturbing dreams may create lingering unease. This emotional carryover demonstrates the genuine psychological impact of dream experiences, even though they occurred entirely within your mind. The relationship between sleep quality and dream content is bidirectional. Poor sleep quality can lead to more negative dream content and nightmares, while disturbed dreams can worsen overall sleep quality. This cycle highlights the importance of healthy sleep for psychological well-being, and the role dreams play in that relationship. Different neurotransmitter systems influence different aspects of dreaming. Acetylcholine promotes the vivid imagery and narrative flow of REM dreams. Reduced serotonin and norepinephrine allow the bizarre and emotional character of dreams. Dopamine may influence motivational aspects. This complex neurochemical orchestra creates the unique phenomenology of dreaming. The sleeping brain processes emotional memories differently than neutral memories, with emotional content receiving prioritized consolidation and integration. This preferential treatment ensures that emotionally significant experiences, which are most important for survival and well-being, are more likely to be retained and integrated into your autobiographical memory. Dreams may serve as a form of mood regulation, helping to maintain emotional equilibrium across days and weeks. Processing emotional experiences during sleep, particularly negative emotions, may prevent the accumulation of unprocessed feelings that could lead to mood disturbances. The regular opportunity to work through emotions during nightly dreaming contributes to overall emotional health. Your brain's circadian rhythm influences when and how intensely you dream, with REM sleep and associated dreaming becoming more prominent in the later hours of the night. This circadian influence explains why dreams near morning tend to be longer, more vivid, and more memorable than earlier night dreams. The neural correlates of specific dream content can now be partially identified through advanced neuroimaging and machine learning techniques. Different dream experiences, such as seeing faces versus landscapes or experiencing fear versus joy, produce distinguishable patterns of brain activity. This emerging ability to decode dream content from brain signals represents a significant advance in understanding the neural basis of subjective experience. Dreams about examinations, public speaking, or being unprepared for important events often reflect performance anxiety or feelings of inadequacy. These common dream themes appear to process ongoing concerns about evaluation, judgment, and meeting expectations. The repetition of such dreams in times of stress suggests the brain uses sleep to work through these social and performance anxieties. The sense of time in dreams can be distorted, with subjective experiences feeling much longer or shorter than their actual duration. A dream that seems to span hours might occur in just minutes of REM sleep. This temporal distortion relates to the altered functioning of brain regions involved in temporal processing during sleep. By now, you understand that your brain doesn't create dreams randomly or accidentally. Dreams emerge from fundamental processes of memory, emotion, and consciousness integration. Your sleeping brain isn't resting, but rather actively engaged in the essential work of making sense of life, processing feelings, strengthening important memories, and maintaining the neural infrastructure supporting thought itself. Dreaming represents one of the brain's most sophisticated functions, essential for psychological health and cognitive performance. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Night becomes day, becomes night again. Breath flows in, flows out, flows in again. The moon orbits Earth. Earth orbits the Sunday. The sun drifts through the galaxy. All are circles, cycles, endless rhythms. Like your sleep cycling through stages throughout the night. Non-REM to non-REM again. A small cycle within the vast universe. You are also part of that eternal movement, that natural rhythm of existence. You don't need to hold on to anything. Let everything unfold in its perfect order, like planets silently rotating in their orbits, unhurried, unresisting, simply existing. We're almost there now. Dreams make you human. No other aspect of mental life combines memory, emotion, perception, and imagination so completely. When you dream, you're engaging in a uniquely human form of consciousness, one that has fascinated philosophers, artists, and scientists throughout history. Your capacity to dream, to create entire worlds within your mind, To feel genuine emotions about imaginary scenarios represents something profound about the nature of consciousness itself. Dreaming is not just what your brain does, it's part of what makes you who you are. The barrier between dreaming and waking consciousness is thinner than it seems. Creative insights, intuitive knowing, spontaneous imagination during waking hours all draw from the same associative processes, operating more freely during dreams. Learning to access dreamlike thinking while awake can enhance creativity and problem-solving. Many meditation practices aim to reach a state combining waking awareness with dream-like fluidity, accessing the best of both modes of consciousness. Dreams connect you to the collective human experience. Every person who has ever lived has spent roughly 1/3 of their life sleeping, and much of that time dreaming. This shared experience across all cultures and throughout history makes dreaming one of the most universal aspects of human existence. You participate in an ancient human tradition each night when you close your eyes and enter the dream world. The mystery of consciousness itself is nowhere more apparent than in dreaming. How does the brain create subjective experience? How do neural firing patterns become vivid sensations, emotions, and narratives? Dreams highlight these fundamental questions because they demonstrate the brain's capacity to generate complete experiential realities without external input. Understanding dreams means understanding consciousness itself. Your sleeping brain doesn't distinguish between dreaming you're running and actually running, at least not completely. The motor cortex activates during dreams of movement, though the signals are blocked from reaching muscles by REM paralysis. This suggests dreams may provide a form of mental rehearsal or practice for physical skills, maintaining motor programs, even during sleep. Dreams about water often feel particularly vivid and emotionally resonant. Water in dreams can represent emotions, the unconscious mind, or life transitions. However, rather than universal symbols, water's meaning in any particular dream depends on the dreamer's personal associations, recent experiences, and current emotional state. The feeling tone of the dream provides more interpretive value than any fixed symbolic meaning. The dreaming brain shows remarkable creativity, generating novel scenarios, conversations, and visual scenes that you've never experienced in waking life. This creative capacity demonstrates that consciousness isn't simply recording and replaying reality, but actively constructing experience. Dreams reveal the brain as a generative system, not just a passive receiver of sensory input. Your emotional life is deeply intertwined with your dream life. The feelings you experience during dreams are genuine emotional responses, activating the same neural systems as waking emotions. Processing emotions through dreams contributes to emotional intelligence, resilience, and psychological health. Your nighttime emotional experiences are as real and important as daytime ones. Dreams can influence behavior and decision-making, even when not consciously remembered. The emotional tone of forgotten dreams may subtly affect your mood upon waking. Unconscious processing during dreams may shift intuitions or preferences without your awareness. The boundary between conscious and unconscious influence is permeable, with dreams operating in both domains. The future of dream research includes developing better methods for dream engineering, potentially allowing people to have desired dream experiences. Applications might include treating nightmares, enhancing creativity, processing trauma, or simply creating positive experiences during sleep. However, such technologies raise ethical questions about the nature and value of spontaneous, uncontrolled dreaming. Your brain generates dreams not because evolution programmed specific dream content, but because dreaming emerges naturally from the brain's basic operating principles. Memory consolidation, emotional processing, neural maintenance, and spontaneous activity during sleep inevitably produce dream experiences. Dreams are an emergent property of brain function during sleep. The question of whether animals dream remains partially unanswered, though REM sleep occurs in many mammals, and some evidence suggests animals experience dream like mental imagery. Sleeping dogs sometimes move their legs and vocalize, suggesting dream activity. However, we can't know the subjective quality of animal dreams, if they exist, in the way we know human dreams through verbal reports. Dreams illuminate the constructed nature of all perception and experience. Even waking consciousness involves the brain generating a model of reality rather than directly perceiving objective reality. Dreams make this constructive process obvious, revealing that all experience is essentially a controlled hallucination, shaped by sensory input during waking and by memory and imagination during sleep. Your dreaming mind has access to your entire memory store, though usually not in an organized or voluntary way. Random or semi-random activation of memory networks during sleep allows forgotten experiences, old emotions, and distant memories to surface in dreams. This access to your complete mental archive, usually outside conscious awareness, demonstrates the vast scope of information stored in your brain. The practice of lucid dreaming, where you become aware you're dreaming and can sometimes influence dream content, represents a unique state of consciousness. Some people naturally experience frequent lucid dreams, while others can learn techniques to increase lucidity. This hybrid state offers opportunities for exploring consciousness, overcoming nightmares, or simply enjoying the freedom of a controllable dream world. Dreams about teeth falling out rank among the most commonly reported dream themes worldwide. Interpretations vary from anxiety about appearance or loss of control to processing actual dental sensations during sleep. The universality of this dream theme suggests it may relate to basic human concerns about health, aging, or vulnerability, though individual meanings always depend on personal context. Your sleeping brain maintains enough environmental awareness to incorporate external sounds, smells, or sensations into dreams while keeping you asleep. This delicate balance allows sleep to continue despite minor disturbances while still preparing you to wake if truly necessary. Dreams serve as a buffer between deep sleep and the outside world. The neuroplasticity of the sleeping brain means that dreams may contribute to learning and neural reorganization. Each dream potentially strengthens some neural pathways while weakening others, gradually sculpting brain structure and function. Over months and years, your nightly dreams cumulatively influence who you become. Dreams sometimes provide comfort during grief, allowing continued relationship with deceased loved ones through dream encounters. While these dreams represent memory activation rather than actual contact, their psychological value is real. The grieving brain uses dreams to maintain connection while gradually adjusting to loss. The dreaming state represents a form of consciousness that evolution has preserved across millions of years of mammalian evolution. This suggests dreaming serves important functions, valuable enough to have been maintained, despite requiring significant time and energy investment. Your nightly dreams participate in ancient evolutionary processes. Dreams reveal that reality as you experience it is always an interpretation, a best guess by your brain about what's happening based on available information. During waking, sensory data constrains this interpretation. During dreaming, with sensory input reduced, the interpretive nature of consciousness becomes obvious. All experience is constructed. Dreams just make this fact undeniable. Your brain's ability to generate coherent, meaningful dreams from the complex neural activity of sleep demonstrates remarkable self-organizing properties. Without conscious direction, sleeping neural networks spontaneously produce experiences with narrative structure, emotional resonance, and subjective coherence. This self-organization hints at deep principles of brain function and consciousness. Dreams connect past, present, and future, They draw on past memories, reflect current concerns, and sometimes seem to anticipate or prepare for future challenges. This temporal integration makes dreams a unique form of mental time travel, linking your life story across time through the nightly work of sleep. The question of dream meaning has no single answer. Dreams mean something because they reflect genuine psychological processes, meaningful concerns, and real emotional states. But they don't mean something in the sense of having fixed symbolic interpretations that can be looked up in a dream dictionary. Meaning emerges from each dreamer's unique psychology and life context. Your dreaming mind is still your mind, just operating under different constraints and with different capacities than waking consciousness. The thoughts, feelings, and experiences of dreams are genuinely yours, revealing aspects of your psychology that may be less apparent during waking. Dreams offer a window into the full complexity of your mental life. The border between sleeping and waking consciousness remains somewhat mysterious. Hypnopompic experiences, occurring during the transition from sleep to waking, can produce brief dream-like hallucinations or confusion about reality. This twilight state demonstrates the gradual rather than sudden shift between consciousness modes. Dreams serve as your brain's theater for processing life. Every experience, every emotion, every relationship and concern finds its way onto the stage during sleep. The performance serves not an external audience, but your own psychological well-being, helping you make sense of life through the unique logic and creativity of dreams. Some aspects of dreaming remain genuinely mysterious. Why do dreams feel so real while happening, but so bizarre when remembered? Why do certain symbols or themes recur across individuals and cultures? Why does the sleeping brain bother creating such elaborate experiences? These questions remind us that consciousness, even in its sleep state, contains depths we're only beginning to understand. Your nightly dreams represent hours of pure subjective experience, as real to you in the moment as any waking experience. The accumulated dream life over decades constitutes a significant portion of your total conscious existence. Dreams are not an interruption of life, but an integral part of living. The neuroscience of dreams has advanced dramatically, but will never fully capture the subjective, personal quality of dream experience. Dreams must be understood both objectively, through brain science, and subjectively, through personal meaning and phenomenology. Both perspectives are essential, and neither reduces to the other. So why does your brain create dreams while you sleep? Because you are more than the sum of your waking thoughts. You are memory and hope, fear and joy, past and future, all woven together in the quiet darkness. Dreams are where you become yourself, night after night, through the gentle alchemy of sleeping consciousness. This is who you are, and so, our quiet journey through the dreaming mind comes to a gentle close. We've traveled from the first moment consciousness fades into sleep to the theater where memories become stories, discovering along the way that dreams aren't random noise, but essential processing. From brain chemistry shifts that unlock imagination to neural circuits replaying the day's experiences, we've glimpsed how dreaming is both deeply personal and universally human. The sleeping mind reminds us that consciousness never truly rests. Much of what makes us human happens in silence, in darkness, in the private theater of dreams. They teach us that processing experience, integrating memory, and maintaining emotional balance require this nightly journey inward. Without dreams, we would lose part of ourselves. By pausing to understand, we glimpse the extraordinary in the ordinary. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about unity, of every thought, every dream, every moment of consciousness across all human minds. You are not separate. You are a link in the endless chain of awareness. Think about how every person sleeping right now dreams their own dreams, processes their own memories, works through their own emotions, all connected in this fundamental human experience of dreaming. Let your entire being dissolve into the gentle darkness, into the soft rhythm of breath, into sleep's embrace. Prepare for deep sleep. No boundaries left, only peace. If this thoughtful exploration of the mind made you feel less alone, whisper it forward to someone awake tonight. It may bring comfort to one more wandering consciousness, one quiet share, one peaceful night at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, through the landscapes of consciousness, memory, and dreams. You can allow these thoughts about the sleeping mind to fade now, like morning mist dissolving in sunlight, leaving only the gentle calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself has grown softer, gently pulling you down into the mattress, into the bed, into stillness. If sleep comes, let it carry you like a leaf floating down a slow river, smoothly, inevitably, into a realm where time and weight no longer matter, where consciousness dissolves into the peaceful darkness that has welcomed humans to rest since the beginning of time. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, your brain will still be creating dreams. Memory consolidation will still occur. The ancient rhythms of sleep will still carry you through the night. But tonight belongs to stillness. Rest well, dear dreamer. And remember, you are not just a body lying in darkness. You are consciousness itself, briefly pausing between waking stories and dreaming stories, resting in the space where both become one. Fall asleep to gentle science. Dream deeper with bedtime psychology. Relax, listen, and drift into sleep. Good night.